Today, everybody, we're going to be talking about the properties of logarithms. We're going to talk about the product property. We're going to talk about the quotient property. And most importantly, we're going to talk about the power property. Because once you guys know the power property, you will be able to say, I've got the power. All right, so right now we're going to look at problem number 1. Now, on this assignment, we've given you some approximate values that you're going to be using. One of them is this. Log base 12 of 3 is approximately equal to 0.4421. Now, what that means is this. If you took the number 12 and you raised it to the power of 0.4421, that would approximately equal the number 3. Now, another piece of information that they've given you on problems 1 through 9 is that log base 12, bless you, of the number 7 is approximately equal to 0.7831. Is that correct? Looking at your papers? Can you please stop taping? Thank you. Now, this means 12 raised to the power of 0.7831 would get you ridiculously close to the number 7. Let's just see if that's true. Oh, that's all about exponential numbers. 12 raised to the power of 0.7831. Let's see if that works. Hey, look, what's that really close to? 7. And 12 raised to the power of 0.4421 is really close to the number 3. Okay, so we're using these approximate values, everybody. So make sure, in your journal, could you please make sure you write this down and this down, as well as the problem. So make sure you do that now. All right, now that you guys have written that down, remember, this is logarithmic form, this is exponential. This is logarithmic, this is exponential. I want you guys to understand that the number 21 can also be rewritten as 7 times 3. 7 times 3 is the number 21. Now, the first thing we're going to talk about is this wonderful property called the product property. Okay? The product property states that if you have a logarithm, I'm going to call it base b. Okay, that was awesome. Of m times n. So, of two numbers, let's say, for example, one of the numbers was the number 7, and the other number was the number 3. That would equal the logarithm of base b, m, plus log base b of n. Now, this is called the product property. You're like, wait a second. If it's called the product property, why are we adding things together? Shouldn't we be multiplying things together? Now let's go back to the exponential world. We're going to talk about one of the laws of exponents. One of the laws of exponents was also something called the what? The product property. And the product property in the law of exponents was if you have a base raised to the power of n times the same base to the power of n, what were we allowed to do with the exponents? Add them together, right? In a similar fashion, in logarithms, because logarithms are the inverses of exponential functions, we are still allowed to do what? Add them together. So if I said log base 12, because our base is 12, and I took the number 7 times 3, how could I rewrite it using this pattern? Log 12, 7. Plus log 12, 3. What is 7 times 3? 7 times 3 is 21. So these numbers have to multiply together to equal the number that you started with. Now, do we have the approximate value for log 12? It's point what? 783. Do we have the approximate value for scrolling up? Log base 12 of 0.4421, right? So everybody, our final answer to this particular problem will be the sum of this number plus this number. When you add those two together, you get 1.2252. Is that correct? Now, everybody, this is your final answer. So your final answer of log 12 of 21 is approximately equal to 1.2252. Now, what does this answer mean? That's one of the things you need to ask yourself. What the heck does that mean? That means that if I wanted to change this to exponential form, I could say 12 raised to the power of 1.2252 should get me really, really, really close to what number? Let's see if we got it. Let's see if we got it. Right? 12 raised to the power of 1.2252. Enter. What's that ridiculously close to? All right, now, everybody, this is a new concept. So knowing that it's a new concept, I want you guys to write some examples down so it'll help your brain recognize the patterns. Here we go. I want you guys to write log. I'm going to put base 12, except this time I'm going to put the number 24. And this is not a problem on your page. This is not a problem on your page. It's just an example. I'm going to show you two examples, and you're going to come up with two on your own. I'm writing some equivalent statements. All right, so here's what I've written down so far. I've written down log base 12 of 24 can equal log base 12 of 24 plus log base 12 of 1. Why? Because the product between 24 and the number 1 is 24. This one here, what's the product of 12 and 2? 24. What I'd like you to do is you come up with two others. Don't tell them to me yet. If you're watching the video, what you can do right now is you can come up with two more examples of your own and see if your examples end up matching our examples. So right now we'll pause the video, because if you don't pause the video right now, you're just going to see the answers pop up on the screen. Do I have a volunteer? Anybody want to tell me two numbers they put there? Yes, Tatum, go. 8 and 3. Brooklyn. 6 and 4. Both of these, we'll put a check, we'll put a check. These all would be the exact same answer. You can get the exact same answer multiple ways of representing the same problem. These products equal 24. These products equal 24. Now, if you wanted to be a smart aleck, you could say log 12 of a half plus log 12 of 48 if you wanted to. Because what's a half times 48? 20. That's another way of writing it. Okay? So what are these? This is called the product property. They always have to multiply together to equal what? That number right there. Okay? So right now, what we're going to do real quickly, we're not going to finish this problem. We're just going to set it up for you. All right? Here we go. Log 12, 49. Does everybody agree that 49 can also be rewritten as 7 squared? Or 7 times 7, right? So if you wanted to, you could say log 12, 7 plus log 12, 7. Do we have the approximate value for log 12, 7? We do. It's what? 0.7831? 0.7831. By the way, how many of these do you see? So you know what? If you wanted to, you could also simplify it to you have 2 log 12 seconds. That's another way of looking at it. Now, by the way, what we're going to do right now for problem number 3, we're going to talk about something called the power property. So right now, I want you guys to write in your journal. Okay? Write in your journal, power property. And the power property states this. If you have a logarithm, base p, and you have n to the power of n, this will equal n times the logarithm base p of n. I want you to see something. See this n value? This n value? What you're allowed to do is you're allowed in a logarithm to take whatever power it is and just bring it right down in front of the logarithm. So here's what we did in our problem. We had the log base 12 of 49, which I could rewrite as log 7 squared. What's our power in this particular example? 2, right? Squared. I'm allowed to bring this down in front. And if I bring this power down in front, that's 2 times the log 7. And you could simply take 2 and multiply it to the 0.7831. Does everybody know that the product of 2 times 0.7831 is the same as 0.7831 plus 0.7831? And that will be your final answer. This is called the what? The power property. Okay? Alright. Now, what I need you guys to do next is put problem number 6 in your journal. We're going to apply not only what's called the power property, we're going to do what's called the quotient property. Alright, so above number 6, what I'm going to write quotient property. Here's what it says. If you have a fraction, you're allowed to take the logarithm of that number and take away the logarithm of this number. Why are we allowed to do it? You guys remember in the law of exponents, the quotient property, if you had a, the power of n over a, power of n, what are we allowed to do with these exponents? That's right, we're allowed to subtract. So what I want you guys to understand, this is the law of exponents dealing with the quotient property. This is the law of the quotient property with logarithms. I'm going to highlight some things. Okay, so I've color coded this to try to help us. Okay? Now, our base, everybody, is just simply the number 12. Okay? So I'm going to write log, I'm going to write it 12, right? So, what number am I going to plug in? Right here. 27. How about right here? 49. That's the first step, everybody. That's the first step. First step is just simply taking these and doing what? Putting one right here, one right here, taking them away. Now, the next thing I'd like you to write, you can write this down in your journal. I want you to understand that 27 is the same as 3 to the power of 3 minus log base 12 of 7 raised to the power of 2. So hopefully, as you're watching this, you can see that these mean the exact same thing, these are the exact same. I'm going to do the long way. I'm going to do the short way. Here's the long way. The long way is understanding that 3 times 3 times 3 gets you to 27. So if you wanted to, you could write log 12, 3 plus log 12, 3 plus. Yes, so I call it the long way. This is not wrong. It's just longer than you need to make. How many? How many of these will you see? You will see a total of 2 of them. Now, if we wanted to, everybody, if you wanted to, you could take this power and you could move it where? Move it right up front. You can take this power and move it right up front. How many log base 12 3s do you have? 3. You have 3. So you can skip all of this. You can skip all of it and just write 3 log 12 3. And you could skip all of this and write, how many log 12 7s do you have? 2. All right, now to finish this problem off, you guys have approximate values for this guy, which is 0.4421, and you have approximate values of this guy right here, which is 0.7831. Now you're going to get an approximate value that's negative negative 0.2399. Now this is your final answer. Now that you have your final answer, what I'm going to do is I'm going to say this right here is approximately equal to a negative 0.2399. Now check this out. I'm going to go around the world, and I'm going to say 12 raised to the power of a negative 0.2399 would get me ridiculously close to that right there. Oh, go back. 3 times this minus 2 times this. All right, last problem, everybody. We're going down to problem number 7. First thing I'm going to do is I'm going to highlight the 81. I'm going to highlight the 49. Okay, we're going to do what's called the quotient property. We're going to say log 12 of 81 minus log 12 of 49. That's the first step. All right, next thing I'm going to do is I'm going to convert the number 81 to 3 to the power of 4. And then I'm going to convert the number 49 to 7 squared. Log 12. Once you've done that, then you get to use the wonderful concept called the power property, which saves you so much time and energy. It's ridiculous. If you move the 4 up front, what does that give you? It gives you 4 log 12 of 3 minus 2 log 12 of 7. All right, now that you have everything set up, just do 4 parentheses minus 2 parentheses. On your paper, it tells you that log 12 of 3 is at 0.4421, and log 12 of 7 is 0.7831. Now these approximate values are on your paper. Whenever you type that into the calculator, you get your approximate answer. And you highlight it up. Keep doing this process for the rest of the problem.